let's get started because I know I'm standing between you and lunch, and you're like, just get this done. So thank you for coming. Before we get started, I just want to get a gauge of, what your experience with AI is. So I'm assuming everyone here has used AI in some fashion or another, so I'm not going to, like if you use ChatGPT or Claude. But how many people are mostly using AI when they're writing code in like a autocomplete fashion? So more than anything else, like that, is that your main mode? And how many people are using sort of chat systems to generate some code, but not like letting chat run on its own into an agent fashion? Okay, about a third of you. And who's just letting the agents do all of their code writing? No shame. I'm about to introduce myself, so. Great, so that was like maybe a quarter. I don't know what the rest of you are doing. That math doesn't add up great. So today I want to talk about AI, and specifically, I'm going to talk about the state of AI today. Now, someone on the internet is going to yell at me about like, you just don't know what the future of AI is going to look like. Agents will be running the world and all these things. Fine, someone on YouTube can yell at me later. But today, we're really going to talk about how AI is working today and how you, as a software engineer, can really use AI to accelerate your code. So a little bit about me. I work at Agentic Code. I run product there, but I've also done about everything else. I've been there for most of its existence. I wrote the CLI. If you use Augie, the CLI. Anyone an Augment user? It's okay if you're not. No shame. All right. Well, I'm going to convert you all now. But I wrote the CLI, which might be familiar with like Claude Code. And so now I use agents for almost exclusively. I almost never use even tab completions or autocomplete. I'm usually using the agent to do almost all of my coding now. And I'll talk about like how I can do that and kind of hopefully give you some tips on if you want to head that direction. But it's exciting to see a room this full about people excited about AI and what we can offer there. But I do have some bad news. Next year, this time, only about half of you are going to be here. Sorry, that's if you believe some headlines. How many people have seen a headline like this? Pretty dramatic, right? This is now 6 months old. These are all from around May and April. How close do any of you think we are to this state of affairs, right? Like we've got someone saying 12 months, right? Like that says Zuck saying 12 months from now, AI is going to write a bunch of code. There's a bunch of reasons why I think we have this sense. One, we're going to pick apart what it means to write code versus being a software engineer. So there's a little bit of that. But also something that's more important in these systems. One, I don't think any of these people have carried a pager in the last 20 years, if ever, in their careers. And so like, I've carried a pager for a long time in my career, so I work on AI systems that write code, and I'm like, I'm not going to let it write all of my code exactly that way, where it's just like, oh, all the code is being written by AI. But a few things that are important to note. One, these are massive code bases. If you've ever worked in a very large code base, how many choices do you actually get to make about the architecture, the design of the code you're building, the sort of interfaces you're working against? Most of those decisions are made. So like the constraints are pretty limited to begin with. So like, yeah, I think AI can write pretty good code when you've constrained it so tightly that it needs to fit within this pattern. That's not that difficult. Second is, it's just code still. Like, we're still just building a faster horse at this point in time. We haven't changed how code is written entirely. We're still writing the same Python. We're still writing the same Java. But like, it needs to run still somewhere. Like, yeah, sure, it can actually like generate code, but does it run in production? What happens when a production issue comes up? How does it resolve those things? And I do think there is a world in which we see AI solving some of those problems, but we're not there today. And then history repeats itself a lot. Like, this is not the first technical revolution which we've had, hey, everybody's going to lose their jobs. Tractors did not put farmers out of business. They put horses out of business. Horses now get to live a nice, graceful life in a field. But like we saw an industrial revolution with tractors, right? We've seen it with cloud computing, right? Like how many people knew a sysadmin in the early 2010s that like is now just working at a Starbucks? Like, no, we changed the job entirely, right? Like most of those people changed to go do site reliability. They moved on to distributed systems. Like the whole system just changed around it. It wasn't like, and 15 years later, how many times do you hear in a week someone talking about digital transformation, migrating to the cloud. It's been 15 years and we're still talking about this problem. Some of you are probably even working at places that are talking about this problem. So technical transformation doesn't happen overnight where like everybody just lost their job. At least we've got 15 more years, so that's not too bad. And there's a lot of talk about vibe coding. And I don't have any problems inherently with vibe coding, but we are not talking about vibe coding. Vibe coding, in my definition, and what theoretically it should be defined as, is AI generating code and you not caring about the code. Do you care about the outcome? Right? Does it put the button where it's supposed to put it? Does it do the actual database update that it's supposed to do? But the actual quality of the code, the actual organization of the code, vibe coders don't care about that. One, because a lot of people got introduced to coding for the very first time, right? This amazing opportunity is that we expanded the world of who can write code, and that's great, but we all have been writing code for, I don't know, let's say average 10 plus years here. And so the way we approach code is going to be different than someone that's just been introduced to it. So we're not talking about vibe coding, we're talking about writing real software in production. And so, if, again, anyone carried a pager or are currently on call, how many people had to deal with the Cloudflare issue this morning? Did anyone know that there's a Cloudflare issue this morning? Or were you all asleep? It's cool. Lucky you. So if you've got 4 nines reliability, like AI is not answering that page at 2 in the morning, or in this case 5 in the morning when Cloudflare went down. And so we need to care about the code and how it's written. So what we're really talking about is AI code you can ship to production. So I found something really fascinating is in every other technical transformation that I've seen, my friends, my peers, people in the industry, community have adopted that technology faster than anyone else. Rust came along, and I swear to God, everyone's like, rewrite everything in Rust, right? Cloud came along, moved to the cloud. AI has not been that way. There's been a lot of hesitation on software engineers who normally would adopt new technologies to adopt AI. And I think that's a super fascinating experience. And some of it is, a little fear about am I going to have a job? Is this going to take my job? But I don't think it's exactly that. I think there's also a huge component about the kind of code and the quality of code AI is generating and how to make sure that that code is good. Also, as software engineers, we hate black boxes. LLMs are a giant black box. Working very closely with AI researchers has been really fascinating. For someone that's always wanted A plus B to equal C, right? Like I carry a pager. The system is supposed to always do this thing. An LLM and an AI engineer is like, that's okay. It's okay if it doesn't do the same thing every time. You're like, no, I've spent a whole career making sure software does exactly what I want it to do every single time. And so that's, I think, a very big difference between, I would call us production engineers that have been working on production level systems and people that are working in AI engineering, and it's just a whole different worldview. So keep that in mind as we talk about why this adoption curve is a little low. So first, let's talk about what is the job of a software engineer. Were people that were building using punch cards doing software engineering? I would say so, probably. Does it really matter how the code gets input in order to call it software engineering? Probably not. So one, I know some people here love programming languages, love the craft of writing languages and what they can do, and that's awesome. But that isn't necessarily the job of software engineering. Our job isn't inherently to write code. Our job is to solve problems, and we have been changing the way we solve those problems. Punch cards, we've invented frameworks, we've invented, all kinds of things over the years. And so, think about what does the job of a software engineer do? Writing code is more of an artifact. If you've ever remodeled your house, is the blueprint the job of the architect, or is that an artifact of the work they did? Is your job the blueprint, or is it all the thinking that goes into why the bathroom is there and how the electrical system doesn't burn down your house and all those things? So I want you to think about, if you can, divorce yourself from writing the code and think about what are we trying to do in software engineers. We also have a love-hate relationship with software. We love writing code. Who hates maintaining code? Hands, safe space. Especially who hates maintaining other people's code, right? How many times, who would get blamed themselves accidentally? Like 6 months ago, I write that code and I hate maintaining. Like, why did I do that? So we have this like weird relationship. We want to generate code, but we don't want to maintain it. So like that seems really weird. And then code has this very like odd sort of relationship in the world. Jeff Atwood of Stack Overflow fame, says the best code is no code at all, because every bit of code is kind of a liability. Every line of code you write is something you have to maintain, something you're going to have to debug at some point in time, something else somebody else is going to have to maintain. So really, writing code can't be the job of software engineering, because our goal really is to write the least amount of code possible. At least I want to write the least amount of code possible. So that can't be the job of software engineering. And all code has trade-offs in it, right? Like the way you design a system, there's trade-offs to that. Which programming languages, which frameworks you use, all of those are trade-offs you're making. And you as a software engineer have to make those trade-offs. AI, we'll get to in a minute, is a text generation machine. It doesn't know how to make trade-offs. And so in software engineering, we really want to think about what kind of trade-offs are we making to engineer the system and build the system. Think about all the trade-offs you would have to make if you were designing a system that is either a monolith, a microservice, or an event-driven system, right? Like there's frameworks, there's architectures, there's compute, there's just boundaries, APIs, abstractions, pick your thing. Right? There are 1,000 little trade-offs you're going to make as a software engineer in that point. None of it has to do with the actual code that's being written. It has to do with how does this complex system work together? How does data flow through it? And how do I make sure it stays up and around? So that has nothing to do with writing code. And the thing about just generating code is like these complex systems are a little like a spider web. You can't just be like, oh, I'm going to reproduce this like chunk of code that I saw 1,000 times. That's what LLMs do, right? Because like it has a bunch of built-in scenarios with it, right? Like all of those trade-offs are a bit of a spider web. You can't just like pluck this one thread of a spider web away and not expect the rest of it to move with it. It all has to change together. And so just generating code randomly, which is fundamentally what's happening, is not the job of the software engineer. So like how do we build in all of that into AI? So I like to think of software engineering as fixing that plane while it's in flight. Basically, my job is to make changes safely, right? And we built lots of systems over the years in order to make changes safely. One, I just have years of experience. I've been doing this for a long time. I've seen a lot of stuff. I've answered a lot of pages. There's version control. We have version control to like slow down safety. There's testing frameworks, right? So like, when you make a change, the changes that don't impact other teams. We've got type systems, right? Like that's a form of building of safety built in. And so how can AI potentially help us do this, right? There's a lot of context that goes into writing software. I used to spend, let's say 4 hours to make a 45-minute change, right? Like I read a lot of code, I get the whole system in my head, and then I'm like, great, now I can make this change, maybe take me 45 minutes at best. That's a lot of energy that goes into just consuming a bunch of context to then do a little bit of work. And we do that over and over and over again. We're constantly onboarding to new code. And so like, how can AI help us do that work? So, like it or not, AI is writing a lot of code. Like this is not gonna, I'm just gonna tell you, it's not going away anytime soon. So like, how can we actually roll with it? And so I want to talk about some tips on how like I use AI. Anyone here think that code is still your job? Anyone think that before we started? It's okay. Great, then we're all on the same page. Generating the code is not the problem. So how do we actually write good code using AI and do that efficiently? So I want to kind of dig in just a little bit on like why software engineers maybe don't adopt AI as quickly. One, the future's here, right? Like there are people like myself who are using agents all day. There are some people that are using like 100 agents a day. I don't have the mental capacity for that. I use like 1, maybe 2 agents simultaneously. I don't know, maybe I'm doing something wrong and I'll learn. And there are people that are just getting into it. But I think some of the reasons we don't adopt AI is like, we have this fear of like not invented here. Like if I didn't write that code, is that code worse because of it? Is it maybe not in my style? Our coworkers write code all the time, not in our style, and we still merge those PRs. And so does that matter? Is there a bias for perfection that comes in? Like it has to be exactly right versus like, that's good and it does its job. Again, this is just a coworker fundamentally. You approve PRs all the time from people that write code differently than you do. Is this really that different? And so, we've really migrated on where we're at today. So 3 years ago, Copilot came out. We were just doing like autocomplete, which is fine, nice. I think a lot of I used to work at GitHub. Unfortunately, I think GitHub did a little bit of a disservice to the world where the code that in those early days, everyone got exposure to it, it just wasn't very good. And that's okay. It's not Copilot's fault. That's just where LLMs were at the point in time. So everyone kind of got a bit of a taste of like, this is fine. I'm not going to do more of it in those early days. Then, a year and a half ago or so, we got really good at chat systems. So we were doing, just a sidebar where it's like, hey, refactor this thing or give me, look up this documentation. How would I implement it? It would generate some code. And then maybe 6 months ago is when we got agents, give or take. Agents really took off. So they're very, very new. But that's where we're at today. And so I want to help you get to the agent world because I think it can be very powerful. And so how can we build software that AI can write? Like that's the fundamental question. First rule, have documentation standards and practices. So every code base I've ever worked in is like 30% cruft, 30% like still works, it's fine, and then like 30% is like the new hotness. Like this is the greatest and latest thing. We want to document where our code bases are and where they're going. Which framework should it be using? Which patterns should it be using? Document those things. If it helps you, you can also think about this instead of building software that's easy for an AI to write. How is it building software that's easy for an intern to write? You would probably document a bunch of stuff, right? Okay, so let's do that. Let's have simple reproducible environments. The most powerful thing agents can do is actually run code. So they can execute things in your terminal. They can run the same linters that you have, the same build systems that you have. But you need an environment that actually looks like your environment. So have reproducible systems and environments that allow them to do that. Because then they can see the error and then fix it. I'm going to be really, really honest here. I have never one-shotted a piece of code in my life. I've never written a piece of code that didn't have an error in it when I first wrote it, of any substance. So why do I expect an AI to be able to do that? I use linting systems, I use test systems. Like something has always gone wrong in some piece of code I've written for my entire career. And there's no shame in that. We have this like weird phenomenon where we're like, well, AI should write it perfectly the first time. I don't know why that's the case, but I think that's one of the problems. So have environments in which you can run your code. Having very easy and fast test infrastructure. Do you all have fast test infrastructure here? Not even a single. Well, one hand. Good job. One of my favorite conversations I've had in this space is there was a VP of Eng talking about like wanting to invest in developer infrastructure and like the developer productivity, right? Like make our infra better, make our build systems faster. And the CEO always kept pushing back of like, is that more important than this feature we're going to build? Once AI came onto the world, he was suddenly able to like be empowered to like, if we can make all of this stuff faster and better, we can help AI write some of our code. The CEO was like, yes, let's do that. We should have been investing in developer productivity from day one. So make sure you have good testing infrastructure if you want AI to be able to write code. And establish clear boundaries. Really understand how you want your software to work and where the module boundaries are, where your system boundaries are. This is just writing software. This is what we do all the time. We get leaky abstractions, and those are bad ideas. So how can we establish clear boundaries and really get the AI to do that? And last, really understand the work you're trying to do. What's the last bit of work? How do you clearly define a task, a project? Do you just literally sit down with, maybe a PM says, hey, we need to build link sharing. And you're like, okay. You open up your terminal and you just literally start hacking. I assume you have some sort of specification, some sort of list of features, even if it's just in your head, of like what you're going to build. You're not literally just starting to write code from day one. Now, some of you might be looking at this list and being like, wait a second, isn't this just good software engineering? Like, shouldn't we have just been doing this all along? And this is the most strange, this is the biggest phenomenon I think is really weird. Like, why did we think AI and automated systems should be able to do things that we can't do on our own? And so, do good engineering first is the only way to get AI to be able to write good code for you. AI will write code for you if you don't have these things, but it will not be good. And maybe at some point in time, we can get to a world where AI can generate perfect code for you on the first go with none of this. We are not close to that, and that's okay. And I don't know if we ever will get there, given the sort of non-determinism that exists in LLMs. Maybe we'll have to change how AI generates, but today and in some near future, just do good engineering. Step one. That's how you can get AI to write good code for you. So next, I'm going to give you a list of some actual practical tips for how I do it. These are just a list of sort of 10 things. If you are new to AI engineering, and you're like, I have no idea what I'm doing, I feel like this dog all the time. This is my favorite GIF in the world of I have no idea what I'm doing dog. And I want to talk to you about a few of them. First, you have to know what you want. If you don't have an expectation of what that code, when you were sitting down to write it yourself, was going to look like in the first place, then that's a code smell. Like, I have some idea. Maybe I don't have every method formula fashioned out. I don't know exactly every variable name I'm going to put in there, but I have an idea of what I want that code to look like. And if I was a software engineer doing real software engineering, writing code with my fingers, and I didn't have that vision of what I want my code to look like in the end, I would say that's a code smell, right? Like, that's part of the job is having an idea. So you need to first start with what do I want this thing to look like so that I know how to guide the AI going forward. Next is, never forget that AI talks like a human, but is not actually one. My favorite thing that I've experienced personally was I was yelling at AI one day. Anyone else yelled at AI? Like, stop doing this. I was yelling at AI one day, and I'm like, stop making this change, do it this way. It's in this, @mentioned file. And AI literally said to me, I'm sorry, I scanned that document. Let me read it thoroughly. Take a second to think about that. Does a computer have any concept of scanning a document versus reading it thoroughly? If you were grepping it, or you were catting it in your terminal, here's the output. There's no concept of scanning a document in software. So we've anthropomorphized these things in a way that tricks us into thinking they are doing things that they're not. Never forget they are just text generation machines. That is their job. Maybe I'm the black sheep in the group, in AI group, but I don't think they're thinking. They're generating text, and that's okay. There's nothing wrong. That's an amazing thing that we've created, but they are not in fact thinking. They are just reproducing. And so never forget that. No matter how much you want to think oh, this thing is thinking and helping me, it's just using that to create the next set of text. So keep that in mind. Next is context is absolutely everything. So at Augment, this is what we sort of specialize in. We've built a context engine that indexes your code base. This isn't a plug, this is just facts. It indexes your code base, and then we automatically will present to the LLM what the most relevant code is for that task at hand. That's what we've gotten really, really, really good at. Other systems, you might @mention a bunch of files. You might end up with you might have a prompt that you've just crafted the greatest thing that's ever, the novel. But context really does matter. Showing the LLM the right pieces of information and having it at the right size, right? Context windows kind of fill up fundamentally, and the more information you've shoved in there, the more corrupt that information can get. And so managing your context is really important. So at Augment, we decided to offload that problem. One, because on massive code bases like Augment's, which has millions of lines of code, I can't possibly know everything. especially if I want to be able to be agile and move around the code base and solve different problems from different things, I could either spend days getting up to speed on every system and how it all works together, or I can have a thing that's gotten really good at knowing the problem I have and what code I want. Now, Claude Code, on contrast, does a pretty good job, but Claude Code's just wandering around grepping your code base. Now, grep has, and you can watch it do that, right? Grep has some limitations. Grep literally is looking for strings. Some regex pattern matching is okay, but not intent, not actual patterns of code that really matter. What if I don't even know what the thing is actually called? How would I guess that variable name that I'm trying to find a bug for? And so context really matters. So one, get really good at knowing how to get the right context in your LLM, into your prompt, right? So I think you should augment, but you can certainly do other ways. There's lots of things that go on. There's our system prompt, so that takes up a huge chunk of context. So that's like, say, the red bottom layer. There's the base layer. That's how we've engineered it to shape what the LLM is supposed to do. There's all of the app-mentioned files, all the open buffers you have, things like that. There's recently changed files, right? Like if you're in the middle of a change, knowing what changes have recently happened can give you some good indication of where the code base is going and what you're trying to achieve. It can't just be the static files in the repo. Then there's your prompt. Ideally, you don't write a single sentence prompt that says update this thing to do that thing, right? Like add a blinking cursor. I just recently added a feature in the CLI where terminals send ANSI escape codes for when you don't have them in focus, and I wanted to change the cursor to show that you were in focus or not, so you knew whether you should be typing here or not. And I was able to do that with a relatively small prompt because I had that context engine. I did the same thing in Gemini CLI, which is open source. I asked it the same question of how does this work? And it spit out just an entirely random set of things, because the intention of what I was trying to achieve in my prompt was much more clear when it had code-based understanding. It knew that I was working in a CLI-based system, that I was working in terminals, that I knew there's a bunch of ANSI code escapes already in. Also, don't ever work in terminals. I don't know how they became the most popular thing on the internet in the last year, but we're talking about 40-year-old technology. It's amazing anything works. Sorry, quick aside. So context really matters, and formulating that is really important. All right, we need to give our agents a frame to work in. You don't have to give them every sink and faucet and tile choice that you need. You need to give them a frame to work in. There's a parenting. I'm a relatively new parent. I have a 3-year-old. There's a parenting thing in French parenting of the frame, and you give kids this world. This is where their box is, and they can do whatever they want inside that box. And I think agents are very much the same. I've learned a lot about how to work with agents by being a parent in the last few years. So agents.md is a standard on how every LLM or every agent client can pull in data about your code base. You always want to have an agents.md or a claude.md file. Everybody has their own version. That's very, very important. One, because it helps you define, it's that start of that documentation. The thing that I find people mostly get stuck on is I don't want to write this whole thing myself. It's a blank page problem where you open it up and you're all right, what am I supposed to do with this? Just have the LLM generate it at first and then edit it from there. So what if it's wrong? You can go and edit some lines, but agents.md are a really powerful way for you to say, use this, do this, don't do this. Here's how to run my test. Here's how to run this. And you don't have to let the agent kind of run around your code base, hopefully figuring it out. In a lot of code bases it can, but if you have a complex system, it can't. So design an agents.md file. And then sort of last core tip here is start agents frequently. I throw away agents all of the time, especially if I'm exploring different scenarios. I will have an agent try one direction. If it doesn't go well, if it doesn't go the way I wanted it, don't try to correct it. It's the context. This goes back to the context window. The context window now has a bunch of ideas in it that are not the right ideas, and correcting it over and over I still have to send all that context, like all that history goes with it. And so there's just no way to overcome that bad idea. So just throw it away. They're free, right? Like you can start another one. I use agents a lot to just do small tasks. Like I end up doing, a feature of some kind in one agent, be done with it, start a new one. I see a lot of engineers just like running on the same thread for long periods of time. They're like, because it's there, it looks like a chat box, but it's not. You have to remember that this chat box that you've got here is actually full of a bunch of information that gets sent to the LLM every single time, trying to discern what you want to do with it. So start new agents all of the time. I use a sort of intermediary files to be able to like move around my project. If I have a larger project, I will create a plan document, a plan.md file that has like, here's my general like outline. I load that in as my context, start the agent to do one of the tasks in this big list, kill that one, start another one, and have it update that plan.md when it's finished those things. So use agents to be able to just kind of go wild on it. And I think agents, when you are multiple agents, when you're exploring ideas, like if you're in a more greenfield space of your code base, why not? Like, I don't think you should do like which LLM generated the best set of code, but I think here are two architectural designs that I'm interested in exploring. What does that code look like? Because once I can read that code, I can respond to it. Like, there's a famous line where code wins arguments. So like if I'm debating whether I want this style or that style in my, just generate the code and then like, this one feels right to me. This looks more like the code I want or it doesn't. So use agents liberally and don't try to keep reusing the same one. Don't try to keep one that lives on for the entire history of your giant Java 18 migration. Is that a number? It's Java 18, I think. Does anyone know? I think so. Okay, great. I'm not a Java developer. All right, last thing I want to talk about is code review. How many people like doing code review? 2. It's more than the other question I asked. So I actually think code review is the most important skill you can have if you're working with agents. So my workflow is literally, I have Augie CLI, where I'm doing all of my code generation, and I have VS Code's source control view sitting up on my screen. And so I'm just literally looking at, here are the changes it's made. I'm auditing it that way. I'm using Git a ton to be able to like stage changes as I'm like, okay, I like that, I don't like this. I'm staging changes and whatnot. I'm just doing code review all day long, for the most part. I'm also like telling it exactly what to do. Like, hey, this is a hook that belongs here, rename it this, do it this way. I just don't have to go and do all that typing. I don't have to go and update 17 imports when I change a name for something. Yes, I know JetBrains is very good at refactoring. JetBrains people, don't come at me. But the idea that like code review should have been the thing we cared most about in the first place. I think it's the number one skill, it's the number one thing you probably do in software engineering, like if you're working on a team, is you're probably reviewing other people's code, whether it's to do a PR or whether it's to get up to speed on a chunk of code, you're reading somebody else's code. So you have to get really good at code review. And I actually think our code review tools today, like how I actually as a human being sit in front of a computer and like look at code, are terrible. So if anyone wants to start a startup, rethink how we are going to do code review in the future. Because like a lexicographically listed set of files is not a good way, just because that file happens to start with an A, doesn't mean that's the file I should look at first when I'm like looking at code changes. So that's just I'll be your first investor. But think about how you're going to do code review and that you're going to spend a lot more time doing that. I know that can feel uncomfortable and can feel really like sad because we don't love looking at code in that way. We love generating code. But making sure our system is doing what it's supposed to be doing and the direction it's supposed to be going is what our job is. We're supposed to be making changes safely. And so code review has always been that number one responsibility. And so that hasn't changed at all. It's just a matter of like, now we have something else generating code. I'd be happy to talk about the other 5 items on the list at lunch. If you all want to come and visit the Augment booth downstairs, I'll be hanging out there. I encourage you, if you haven't used an agent, to like take a couple of these practices, and start to play with them. We have source control. You can just try them. They're not going to break anything for the most part. Like I've never had it wipe my computer for me. It's never an rm-rf my machine. So like, I think you're mostly in a safe spot to give it a try, and I encourage you to give it a go. Now, it's not going to be for everyone. It took me a couple days to really get used to it. I was most excited to start doing it when I was able to get Augie to build Augie. When I got Augie good enough to like, I can log in, I can like do the work, and that's really what unlocked for me. So in the meantime, hopefully you came here wanting to do this. And the number one rule is just do good software engineering. Teach your AI how to do software engineering in the same way that you learned how to do software engineering. If anyone says like AI writes code like an intern, I guarantee you they've given it as much as they would have an intern, right? Like they've given it as much skill. And don't go work for that company because they treat their interns really badly. Like, so yeah, that's it for me. You can find me as Amateur Human on the internet anywhere. I'll be downstairs, or upstairs, where are we? Upstairs. I'll be upstairs for a little while at the Augment booth if you want to chat. And thank you all for coming. And I take questions here. I think we've got some time.
Yeah, great talk on the agents in production, but I still hesitate to get them do the production work directly. But when you say start the agents frequently when you're doing the code changes in the same file, so most of the times I use Copilot and it has a feature called auto variable. Like it can select the agent on their own based on the use case that we give as an input prompt. So does it feel like the same, does it serve the same purpose that you mentioned?
So the question is, can Copilot pick whether it should be using an agent for the task at hand? It depends on Copilot's route, basically what we call like an agent router. Like, does it know how to analyze the task and decide what agent profile it should use? Like, you can also create lots of different styles of agents. A code review agent has a different prompt. I don't really know. I think I haven't used Copilot in a long time, but I'm guessing not from feedback I hear from people around them, the community. So, yeah, I try to be more intentional. Yeah.
So I have a related question. You mentioned to start agents often, right?
Yeah.
And some of the tricks you shared was have a planning.md. There was another .md that I'm not really...
Agents.md.
Agents.md.
Yeah, so agents, I'll just real quick, if I don't probably gloss over. Agents.md is usually a file you're going to check into source control, and it's going to live at different directory structures. So like, especially if you're in a monorepo, the CLI has its own agent.md versus like our VS Code extension has a different one because it's telling it to do different things in those cases. Yeah.
Right. So is there a list of these best practices that you can share? I mean, those two files I'll carry in my head, but other things that we can keep track of when using agents in
Yeah, I should write that blog post at some point in time. But yes, there are lots of good resources out there. Like people have been trying, lots of different ideas. And I'm not, Augment isn't the only solution. Like the AMP team from SourceGraph, like they do a lot of great work talking about how to use agents well. Like I think as a community, we're all just trying to improve and use the tools that your company will pay for, and ideally use Augment because I think it's cooler. But there's lots of just internet research. But yeah, if you ping me on the internet, I can send you. I'll share my deck so that at least you'll have that as a baseline.
Hi. So I'd like the way how you structured this presentation because this is like more like describing that we should go back to fundamentals, right? Before applying any AI to our life cycle. But so there is one missing that I always thought that's very important is about. Maybe we were working in the past with. Recommendation that it should be applying smaller pull requests, smaller changes, right? And right now we are in the moment that AI is actually, all the companies are struggling with that. AI is introducing too much changes, right? It's like you see hundreds of files changed, and then teams are reluctant to approve it. So I was wondering, what's your recommendation? How we should, like behave in these situations? What would you thought about that? Shall we come back and really stop and start doing like it was in the past, or shall we reinvent something and work differently?
Yeah, so I would say it goes back to the first principle of do good software engineering, in that like my PRs are still roughly the same size as my PRs were when I wasn't using agents or any AI, because they still have to be reviewed by a human. Like we have a code review system, like tool that's AI powered, that is just an extra layer, but like human beings that augment still review every PR. And so I want to make sure that when I'm building that PR and making it in a way that my coworkers are going to be able to read it well and be able to like approve it quickly. So I do think smaller PRs, are better. And then at minimum, if you have a large change, like if you're not familiar with like stacked PRs, look into like how do you do stacking on PRs so that this PR changes this one and it kind of goes up a layer. So yeah, I think the thing is go back to the fundamentals. Chances are, if you're seeing code changes that are like hundreds of files at once, there's a lot of duplicated code that's being either generated, where it's like, well, we already have that function somewhere. But the AI doesn't know it exists, and therefore just created a whole new set of files, or you're just trying to do too much at once. Like, so yeah, I can't really answer it other than I'm the one that my name is on that PR in the first place. I'm the one that's going to have to maintain that code later. So I should be able to grok what that change is doing. If you submit hundreds of files, PRs normally, and you do that successfully, by all means, continue doing that. But I don't think AI can generate bigger PRs easier. I think it's still the same amount of code that is still consumable, reviewable as like we have been. It's just now I can just do more PRs in a day than I was able to do, a year ago. But my PRs are the same. So that's how I would try to tackle it.
Hi. So I started working with agents, and I got into the habit, like every time before talking to the agent, I open a text editor, write an MD file saying, okay, this is the context, there's a constraints, this is what I want you to do. And then I feed it to the agent, and then it runs, and then I say, okay, this is not right, fix this, fix that. But this loop, it feels long, right? For me, like when you're, maybe it's my style of working, but like when you're coding by yourself without an agent or anything, you start writing, and then you say, oh, this is not right, and then you immediately change course, or say this should be an interface, or this should be a method, or something like that. So do you have any tips so that we can make this loop tighter when interacting with agents so it doesn't feel that sluggish? Sometimes I just feel tired just about thinking, okay, I have to write all this stuff before actually having some code.
Yeah. So personally, and everyone's going to be a little different about like where you want to interface. Like I like writing smaller prompts that have smaller sets of changes and doing that more frequently than I do like trying to craft a world where like here I've thought about every edge case and every scenario that the agent can possibly get itself into and get tied up in, and then like ship that off, and then in 8 hours I'm going to come back and it's going to have built me Stripe. And like that's not going to ever happen. So I personally like to have that smaller set of code, again, because it goes back to my code review, that chunk of code that I'm having it generate, I'm going to go in and review it before I let the agent move on. And oftentimes, like again, I say like I use get a ton. I'm going to stage those changes. I'll leave them there, and then have the agent either make a correction or build the next sort of layer of that problem. Again, the MD file has all of these steps in it, and then I'll either commit those new sets of changes or revert things. And so I use get a ton in order to like move around my code base or move around my project and sort of keep the stuff I like and throw away the stuff I don't, because I'm doing a lot smaller prompts. Literally, like the agent probably is running 1 to 3 minutes at a time before I'm coming back to like work on the next thing. That's just how my brain works. I don't want to sit for 15 minutes writing a markdown file and then be like, okay, I'm going to go to lunch now. Like I've tried that. I haven't found that much success with it personally. So I like being a little bit closer to the change set than sort of letting it run wild. So I think it's going to depend on where you find success for yourself, on like what version of writing specifications do you like to do. I don't like writing, there's a joke, I made a good joke in the company recently. We were talking about like any project that's less than 2 weeks doesn't need to have an RFC of some kind. I'm like, great, so you just told me keep all of my projects under 2 weeks and I don't have to write a bunch of extra docs that have to like get reviewed by a bunch of people. Perfect. So I think agents are no different. Like in this, like I can write this prompt that is relatively small and the change is small enough that like I don't have to worry as much about all these edge cases and getting it done. And then I can move faster because I'm doing it more frequently rather than trying to do it all at once. I don't plan on doing like 10 agents running simultaneously. I can't keep all that code in my head and that like what I want it to do in my head anyway. So yeah, that's my advice from my personal experience.
Hey, I have a question. So with LLMs, hallucinations are kind of inevitable. Do you have any tips on how do we minimize it?
Yeah, so LLMs will continue to hallucinate because they are non-deterministic. And so the better your context is, the less likely the LLM is to hallucinate. And that's not perfect. I will give you a very real example recently. So we just launched Agent Client Protocol. We just built that so like Augie can be used in lots of other editors. And I went to go add Augment in the list of like compatible agents. And I said like add Augment to this list. And it's like, great, I'm going to put it between Claude Code and Cognition. I'm like, that's not how the alphabet works. Like technically it did put it in the right place, but like the LLM hallucinated the alphabet. Because it's the strawberry problem, if you're familiar with that in LLMs. So the better the context, the higher likelihood that it won't hallucinate. And that's where we as Augment have really tried really hard, is that context engine understands all of your code base and sends it the right thing, so it doesn't hallucinate that you have this set of packages that you don't have installed, that aren't in your package, JSON, or here are these libraries that just don't exist, because it is just generating text randomly. So try to constrain it enough with the context that you're giving it. Some of that's like you just have to go and list all those files, use context systems to do that work for you, but that's the only way to do it. And you're still going to run into that from time to time. The key is don't assume that it's not going to do that, and you have all of these safety nets, right? You've got your linter, you've got your test suite, all of those things can run automatically. If it can run your linter, it's like, well, this package doesn't exist. Of course it's going to throw an error, and the LLM can correct itself. So that's the goal, is to get it to like fix those themselves, not avoid them in the first place.
Oh, any last question? We only have 1 minute, so you want?
Hi, this is just a confirmation question. Is it correct to say that the agents.md are the rules that you said?
Yeah.
And
an agents.md is like a rules file.
Got it.
Yeah.
And then I just got this idea while I was listening to you, which was, do you think about creating like versions of kind of like summaries of where the context is as you're making these requests? Because up to this point, I've been doing something very similar, which is kind of like creating kind of like a plan and then like capturing like what the agent is doing and summarizing it. But when you were saying like this feedback loop, maybe I should start versioning it so at least I can like go back and see kind of like how things change, especially if it's like making mistakes and things like that. What are your thoughts on that? Yeah,
so I think you can, your agents file can have like, here's where the source of truth is for this set of things. The LLMs can get really good at knowing sort of the intent if you have enough description in there. So I think that's a really good idea. I use that. I do a lot of that stuff in my prompt itself, as I'm like, hey, there's an implementation of this in the VS Code client. Go look over there, and then like build me the version for the CLI. So because like I just happen to know where that code is. So yeah, I think that's a really good idea. And version controlling these things, I think, is excellent. Yeah. I think we're out of time.
Yeah.
You all want to go to lunch? I will be in the hall upstairs if you have more questions. And really appreciate you coming.
Thank you. Thanks a lot for everyone. Please don't forget to vote on the app. Thank you.